Thank you to Brilliant for supporting PBS.
It made the front page of the New York Times. Ancient DNA over 2 million years old, retrieved from the frozen dirt of Greenland. It was twice as old as the previous record for ancient DNA. It reached back further in time than many scientists used to think was even theoretically possible. And it contained the genetic ghost of an entire ecosystem, one that has no counterpart in today's world, and one that we had no idea even existed. It told of a time when Greenland was green, and how we might borrow genes from that ancient past to help us adapt to the future. Until fairly recently, if we wanted to learn about ancient ecosystems, we basically had only one source of evidence, the fossil record. But the fossil record is notoriously patchy, so the natural history of many places at many times has been hard to uncover, including Greenland, which is 80% covered in an ice sheet that cloaks much of the fossil record of the world's largest island from the eyes and the chisels of paleontologists. But over recent years, a new way of studying ancient life has emerged. One that both fills gaps in the fossil record and is also ideally suited to places like Greenland that are cold, dry, and have been covered in ice for a very long time: ancient DNA. Now, lots of scientists used to assume that the preservation of really ancient DNA, say 1 million years or more, was probably impossible. This is because DNA degrades in the environment as its chemical bonds break from exposure to water, microbes, sunlight, heat, and oxygen, fracturing into ever smaller pieces. But thanks to advances in extraction techniques, as well as computational tools that clean up and stitch together short DNA fragments, the field of ancient DNA has exploded. And we've also figured out where to look for the best preserved ancient DNA. Sites with low moisture levels, low light levels, and that have been very stable over long stretches of time. Think caves, permafrost, and deep sediment layers. These advances have allowed us to find and sequence older and older DNA. In 2013, for example, researchers set a record by sequencing the genome of a 700,000-year-old frozen horse unearthed from the Canadian Arctic. And in 2021, scientists broke that record by sequencing ancient DNA extracted from the tooth of a mammoth found in Siberian permafrost, reconstructing the genome of an animal that died 1.2 million years ago. Then, in 2022, the record was broken yet again when the Greenland team announced that they'd sequenced ancient DNA that stretched back around 2.4 million years. But there was something different about this DNA. While those previous record holders had sequenced the genomes of single individuals extracted from their physical remains, the Greenland team had sequenced a jumble of DNA fragments from over 100 plant and animal species, a metagenome. See, living organisms constantly shed DNA into the environment. You and I are both doing it right now. Gross. Under the right circumstances, short fragments of this environmental DNA, or eDNA, can be preserved over vast stretches of time, even without any physical remains of the organisms that left them. And here, the eDNA revealed an ancient ecosystem filled with species that no one saw coming. It was a unique type of far north forest inhabited by some truly gigantic surprises. Specifically, the team's samples came from a formation near Greenland's far northern tip, within the Arctic Circle, called Courtemanche, which was laid down where a river flowed into an estuary. While this area is now a barren polar desert, a little over 2 million years ago, it would have been totally unrecognizable. Temperatures were between 11 to 19 degrees Celsius warmer, enabling a completely different biome to flourish there, until, thanks to the onset of the Pleistocene Ice Age, the area was cast into a deep freeze. The fragile eDNA of the species that had lived there were covered in a layer of near-permanent ice that protected it from light, heat, moisture, and disturbance for over 2 million years, forming an ideal ancient metagenomic time capsule. But Courtemanche wouldn't reveal its secret lost world easily. The researchers collected samples from the site as far back as 2006, trying over and over again to sequence DNA from the ancient frozen sediment, and failing repeatedly for nearly 15 years. It took until around 2020 for the technology to catch up to what seemed like a crazy sci-fi dream, to reconstruct a more than 2 million-year-old ecosystem just from ancient dirt. But their 2022 paper revealed that they'd successfully sequenced enough eDNA from the sediment samples to reconstruct a rich, unique ecosystem of more than 135 plants and animals. From bacteria and plankton to coral and horseshoe crabs, to ants and fleas, to lemmings and hares, to geese, reindeer, and caribou. Plus a rich collection of plants, including poplar, birch, spruce, and cedar, which would have formed a lush boreal forest that dominated the ancient landscape. An entire previously unknown ecosystem was revealed, filled with a diverse array of species that had called the area home 2.4 million years ago, when Greenland, or this part of it at least, was green. Including one animal that no one expected to find there: mastodon. No other evidence of mastodons had ever been found in Greenland before. This gigantic animal was totally missing from the fossil record of the island, and it wasn't thought to have ever roamed so far north or made it to such a remote spot. Herds of mastodon would have been a conspicuous feature of this ecosystem, but without their eDNA, we might have never known they were there at all. Put together, the ancient environmental metagenomics painted a picture of an ecosystem that simply has no modern analog. It was a unique mixture of both Arctic and temperate species that don't blend in a similar way anywhere on Earth today. And it was a blueprint for the kind of ecosystem we might expect to see redevelop in Greenland in the future. That world was much warmer than it is now, and this ecosystem was so far north that it would have been in an extended darkness for about half of the year, and extended light for the other half, as it is today. And some of the ancient eDNA fragments tell us how organisms survive there, providing a genetic roadmap for the future, and potentially a valuable genetic toolkit too. See, hidden in that mess of DNA, researchers notice an interesting and unique mutation in a gene that once belonged to an ancient poplar tree. The mutated gene coded for a protein called a blue light receptor, and it seemed adapted for more efficiently capturing certain wavelengths of light in the high north, helping the tree to thrive with a limited growing season. It was an adaptation that the fossil record alone could have never revealed, and it sparked an idea, one that has opened up yet another new frontier in the field of ancient DNA. Could genes from the past be borrowed for the future? After all, as our world warms up once more, species across the tree of life will face all sorts of challenges which they currently have no adaptations for. But in some cases, their ancient relatives did. So, around 2023, a new research project was launched to genetically engineer barley with the same mutation seen in the Greenland poplars, and potentially other promising mutations from the samples too. The growth of these experimental plants will be tested under various light and temperature levels to see if they've picked up some of these pre-Ice Age survival tricks to grow faster under more extreme conditions. It's a whole new way to look at ancient DNA. We can do more than just isolate, sequence, and study it now. In some cases, we might be able to harness it too. In theory, modern species could be made resilient to particular challenges by being gifted the genetic adaptations of ancient species that faced similar challenges in the deep past. Crops engineered with the ancient blue light receptor gene and others may potentially be able to thrive at extreme high latitudes as the world warms up and the ice retreats, including in places like Greenland that may well turn green again one day. And so, after being shed into the dirt, buried in ice for an epoch, and rediscovered against all the odds, some of these ancient DNA sequences have now, in a sense, found their way back inside living organisms once again. Pieces of a lost world reborn into this one.
Thank you to Brilliant for supporting PBS. Brilliant is where you learn by doing, with thousands of interactive lessons in data analysis, math, programming, and AI. Brilliant helps build your critical thinking skills through problem solving, not memorizing. And if you're into data analysis, Brilliant recently launched new content in data, all of which uses real-world data to train you to see trends and make better informed decisions. It's designed for learners of any level to start or continue learning data analysis with a fully built-out suite of new content. Students can learn how to parse and visualize massive datasets to make them easier to interpret. And you'll learn with real datasets from sources of retail companies, online streaming services, and more. To try everything Brilliant has to offer for free, visit brilliant.org/eons or click on the link in the description. If you go now, you'll also get 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant.
Also, thanks to this month's Eontologist who helps support our future. Addie, Annie, and Eric Higgins, Carl Wolfel, Jackie Scott Rouston, Jake Hart, John Davison Ng, Juan M, Melanie Lamb Carnevale, Nico Robin, Raphael Hasse, Tony Dye, and of course, Steve. By becoming an Eonite at patreon.com/eons, you can get fun perks like access to a monthly Eons PaleoArt digital puzzle. Subscribe at youtube.com/eons for more Holocene happenings. Cape Copenhagen. So when I go to Copenhagen, I can be really cool. I'm like, oh, it's my first time visiting Copenhagen. I need to go to Copenhagen now. Oh, I mean Copenhagen.
You got it.
Hello. It's my first time in Copenhagen. Can I get the Danish? So stupid.